Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. We are going to see a video lecture series on waveform generators and voltage regulators. So in this video, let us see about comparator circuit. So as you know that a comparator is a circuit which compares two input signals which are analog signals, and it provides an output which is a digital signal based on the comparison of the two input signals. So here we have shown the ideal and practical characteristics of a comparator. So it will compare the two signals and provide an output, either a high or low output. So here I output is given as plus VSAT and low output is given as minus VSAT. So the first one is the ideal characteristics. So here there is a sudden increase in the uh, signal characteristics because it is an ideal one. Whereas in a practical circuit, there will not be a sudden rise. The output signal will vary from high to low in a slow variation because of the inbuilt offset voltages and offset null voltages that are present in the op amp circuit. So in the second diagram, here there is a slope shown which varies from minus Vsat to plus Vsat. So as soon as 2 millivolts voltage is reached, your signal is moving from plus Vsat to minus Vsat. There are two types of comparators, non-inverting comparator and inverting comparator, based on the voltages that are given to the non-inverting and inverting input terminals of the op amp. First, first let us see about non-inverting comparator. So here the left side shown here is the circuit of a non-inverting comparator. So the input AC signal Vi is given to the positive terminal of the op amp, and the reference voltage it is given to the negative terminal of the op amp. So this Vi is compared with the V reference here, and based on the comparison the output is got at the output terminal V0, which is connected along with the load resistor RL. So here the animation of the working of a non-inverting comparator is shown for you to understand better. So when Vi is less than V reference, your output will be low. Here it means that it is minus Vsat. When Vi is greater than V reference, your output will be high, which means that it is plus Vsat. Okay, so there are three conditions here for the working of a comparator. The first one is Vi is less than V reference, where your V0 is equal to minus Vsat, and if Vi is greater than the reference voltage, then your output will be switched to plus Vsat from minus Vsat. And when Vi is equal to V reference, this is the point where the state changes in the op amp. So this is the output signal graph which is shown here. So the first one has a positive V reference and the second one has a negative V reference. So here as shown, when the reference voltage is low when compared to the input voltage. Okay, so when Vi is greater than V reference, your signal output will change from minus Vsat to plus Vsat as shown here. So initially your output is at minus Vsat because at this point from 0 to V reference, your signal is less than V reference. So it is in minus Vsat. When your input signal goes above the V reference value, for this part, your output will switch over from minus Vsat to plus Vsat. Okay, after that again when it comes here, your signal will go below the V reference value. So when it goes below, when Vi is less than V reference, your output will change again from plus Vsat to minus Vsat. So this continues throughout. The same concept is followed here in the right side diagram. The only change is your V reference here is a negative value which is below 0 volts. So here also initially your V input is greater than your V reference value. So your output will be at plus Vsat. So when your input goes below the V reference value, your output will shift from plus Vsat to minus Vsat. Okay, so this is the working of a non-inverting comparator. So you'll be having only two outputs here, either plus Vsat or minus Vsat. Next one is inverting comparator. So the inverting comparator, as the name suggests, which is shown here, the input voltage is given to the inverting terminal of the op-amp and the reference voltage is given to the non-inverting terminal of the op-amp. So here is shown a potentiometer which is used to vary the reference voltage based on our needs. Even in your non-inverting comparator, you can use a potentiometer instead of a fixed reference voltage. So when you use a potentiometer, the voltage can be set, reference voltage can be set based on our needs. Okay. So here also the same three conditions are there. So here it is opposite of your non-inverting comparator. So when your input voltage is less than your reference voltage, the output will be plus Vsat. And when your input voltage is greater than V reference, the output will be minus Vsat as shown in the animation here. So here low represents minus Vsat and high represents plus Vsat. So when Vi is equal to V reference, it changes the state of the op-amp. So this is the output of the inverting comparator. So here also there are two diagrams. The first one represents a positive V reference value and the second one represents a negative V reference value. Okay, so in the first case, initially the output is at plus Vsat because V reference is greater than Vi. That is Vi is less than V reference. So if Vi is less than V reference, the output is plus Vsat here. Then once the input goes above the reference voltage at this point, your output shifts from plus Vsat to minus Vsat. And again, when your input goes below the reference voltage, your output shifts from minus Vsat to plus Vsat as shown in the diagram here. In the second diagram, your reference voltage is negative voltage. So here also initially your input voltage is greater than your reference voltage. So your output is maintained in minus Vsat, and once the input voltage becomes less than the reference voltage, your output shifts from minus Vsat to plus Vsat. So this is shown in the diagram here. Next, we will see the applications of comparator. So the several applications are level detectors. It is used in it's a zero crossing detector, window detector, over voltage protection, and battery monitoring. So in the zero crossing detector, the only difference is that the reference voltage is the 0 volts. V reference is equal to 0 volts. So which means that when your input voltage is positive, your output will be plus Vsat, and when your input voltage is negative, then your output will be minus Vsat. Meaning is when Vi is greater than 0, because 0 is the reference voltage, when Vi is greater than 0 volts, then your output will be plus Vsat, and Vi is less than 0 volts, then your output will be minus Vsat. So this is known as zero crossing detector. So next one is window detector. So window detector, it detects if a signal is within the specific voltage range. It uses two comparators. Next one is over voltage protection. So here it will trip a protection circuit if the input exceeds a particular limit which is represented by the reference voltage. Next one is battery monitoring. So here it will compare the battery voltage to set a threshold for charging control. So apart from this, it is also used as level detectors where it will detect if a signal crosses a particular set voltage. One practical circuit is shown here, which is the application of op-amp as a comparator. So here it is used for temperature humidity monitoring of the soil based on the wireless sensor networks for an automatic irrigation system that controls the switching operation, that is on or off operation of the pump by sensing the moisture of the soil content. So the sensing arrangement senses the moisture of the soil, and an appropriate signal is given by the Arduino board. So this is achieved using an op-amp as a comparator circuit acting as an interface between the sensing arrangement and the microcontroller. Based on the signal received from the sensing arrangement, the water pump is operated. The LCD display is used for displaying the status of the soil moisture content and water pump. Hope you understood the operation of comparator. Let us take up some assessment questions. So depending on the value of the input and reference voltage, a comparator can be named as, the answer is voltage level detector. Second one is zero crossing detectors is also called as, the answer is sine to square wave generator. Next question is name of the comparator that helps to find the unknown input. The answer is window detector. Thank you for watching this video.